Uma universidade conectada com o seu tempo, com a ciência e com a formação humana. A Universidade de Caxias do Sul é uma universidade comunitária que tem como missão produzir, sistematizar e socializar o conhecimento com qualidade e relevância para o desenvolvimento sustentável. Conectada com você, sua vida e seus sonhos. Cerca de 100.000 pessoas levam no seu currículo o nome da Universidade de Caxias do Sul. Mas o legado de uma universidade não pode ser só medido pelo número de pessoas que ela formou, mas também pelos conceitos e ideias que ela ajudou a revolucionar, pelas empresas que ajudou a implantar e até mesmo pelos sonhos que ela ajudou a concretizar. A marca da UX ultrapassou as barreiras do tempo e os limites do espaço. Ela está impressa em milhares de histórias e conquistas e segue sua trajetória de sucesso, preparando pessoas com capacidade para transformar o mundo, criar o novo e antecipar o futuro. Universidade de Caxias do Sul.
Hello, everyone. Welcome to the second day of the Knowledge Cities World Summit. We already had our first session today with the presentation of papers. And now we will start the panels of the day with this plenary panel on knowledge-based regenerative cities. The purpose of the panel is to explore aspects of the restorative relationship between cities and natural systems. I would like to introduce you to the chair of this session, Professor Tatiana Tucunduva, Felipe Cortesi. Professor Tatiana is professor of Uninove, of the graduate program in Smart and Sustainable Cities, and she is researcher at the Institute of Advanced Studies, Global Cities, a program of University of São Paulo. She is also the author of the books Smart and Sustainable Cities and Climate Change from Global to Local. His research is focused on the areas of resilient and sustainable cities, smart cities, urban and regional planning, environmental law, climate change. Thank you, Professor Tatiana, for being with us today and for accepting our invitation to chair this panel. Thanks also to our distinguished panelists. I leave you now in the hands of Professor Tatiana, who will make the presentations and lead the panel.
Thank you very much, Professor Ana. It's a great pleasure to be here with you. I appreciate the invitation to be chair of this panel with such wonderful researchers and professors, which I already thank Professor Catherine, Professor Marengo, Professor Marcos, and we'll have a nice discussion today about the knowledge-based regenerative cities. And when we think about living in cities, there's a wide variety of regenerative solutions. And much is currently said about solutions based on nature, where nature is an integral part of the solution. And disregarding the living beings that participate in our urban life, we worsen their quality of life and ours. If we consider living beings, bring them closer, incorporate them into these solutions, this is the way of doing it and improving quality of life. So there are many possibilities, and we'll bring today to this panel some of the researches and the points of view of our invited guests, which I'm proud to present. The first one that will listen in this panel is Professor Catherine. Professor Catherine Zungerling. She's a legal scholar and works primarily in the areas of international environment, energy, and planning law, as well as sustainable urban development. She heads the junior professorship Transformation to Sustainable Energy Systems since August 2019, and the research group Urban Footprints, funded by a fellowship of the Volkswagen Foundation since January 2018. Previously, she had been researching and teaching as a postdoc at Hafen City University, Hamburg, since November 2015, particularly in the context of the master's program Resource Efficiency in Architecture and Planning. From May 2011 to October 2015, she worked also as a lawyer in the Hamburg law firm Gunther. Oh, Professor Catherine, this name is difficult. It's Gunther Heschenwald. You may correct me, please. Mainly in the areas of energy, construction, and environmental law. Professor Catherine, thank you very much for being here with us, and it's your time to present.
Thank you very much, Professor Ana, and also Professor Tatiana, for this very nice welcome and the invitation to this very interesting panel. I'm very much looking forward to our discussions, and I hope I can now present a good startup contribution to our fruitful discussions. I'll share my screen now, and once I've shared it, I will not see you anymore, so just start talking to me, then I will hear you whenever something should go wrong. So let's see. Here comes the slides. Okay, so I hope that this works. And yeah, so let me start. I want to give a talk on understanding and governing the city of flows as a bit of an introductory statement maybe on the topic, and refer to research that we've been conducting in the context of the Urban Footprints project that you have been also referring to in your introduction. It's an ongoing 5-year research project. I started in Hamburg and took over to Freiburg with my team. We're not a big team. We are 3 PhD students and me working on that topic. And I will present some interim results. So first of all, I would like to dig a little bit into the meaning and definition of regenerative cities, and then switch over to understanding and governing the urban metabolism, and then dig a bit deeper into a very specific example on how we could understand and govern urban phosphorus flows and thereby contribute to a more restorative relationship between people, humans, and nature. So first of all, the meaning of regenerative cities is really going beyond sustainability, and I found this graph in a publication of Herbert Girardet, who's one of the contributors of developing the concept of regenerative cities. And there was also at some years ago a conference at the Hafen City University in Hamburg where Girardet, together with the Commission on Cities and Climate Change, developed a bit more of this approach of a regenerative city. And the way it was defined there was that it actually goes beyond sustainable urban development into something that wants to really structure a restorative relationship between humans and nature, but also considering social structures, cultural concerns, and it's going 1, 2, 3 steps further than what we currently understand under sustainable urban development. And it considers that we have already destroyed quite a lot of the environmental fields in urban systems, and that there is also a need for restoration. A very typical graph you've seen probably many times, but very fundamental for this kind of thought, is that we are trying to change from cities and the linear metabolism that we find mostly nowadays, where you have lots of flow inputs of food, energy, and goods into cities, and lots of outputs in terms of waste emissions on global hinterlands, regional or global hinterlands. We want to transfer this to a more circular urban metabolism, where you see those arrows here, inflows and outflows become smaller, and there's more to be organized in those more circular loops within the city, without exploiting too many resources and without producing too much waste that has to be dealt with outside the urban metabolism. One of the key ideas of this Urban Footprints project that I'm working on is also how we can contribute to switching basically from here to there. And I will show you a bit of how we try to do this. So we are trying to understand and govern the urban metabolism. It's inherently interdisciplinary project, so I'm coming from a legal perspective, but my PhD students, for example, are coming from the field of urban planning, and we also architecture as well, and we also look a lot into environmental sciences to understand urban carbon and resource flows. So that's the fundamental research question of the Urban Footprints project. What is the status quo and what is the potential for the accountable governance of cities' carbon and material footprints? So how can we get from large footprints as we have them nowadays to smaller footprints by really understanding the urban metabolism numbers-wise, I'd say, in terms of carbon and material flows, but also in terms of regulation, how can this actually effectively be addressed? Planning, of course, is a large component of that. And we research this in this kind of analytical framework. So we are interested in 3 different perspectives. We look into inner city strategic planning, but then also look beyond the city scale and look into how cities are involved and connected to larger vertical scales of government, so like connected to multilateral environmental agreements, like the Paris Agreement, for example, and also to the level of states or provinces, depending on in which jurisdiction you are. You have different levels in the vertical governance system. So this vertical hierarchy is important for us as well, since it shapes the local scope of action quite a bit. And then we are also interested in this polycentric dimension here. So how do cities cooperate amongst each other? And I know there's a lot of networking going on among Brazilian cities, same for Europe, and also more and more global networking over ICLE, C40 cities, and other city networks. And we are interested in understanding what we call accountability chains and accountability design. So how do cities take over responsibility for certain resource flows, and towards whom, and how is this then equipped from an instrumental perspective? And now I will zoom in a bit more into this city level, since this is the focus of this panel. And here we try to apply this accountability analysis framework, where we look into responsibility, assessment, transparency, and participation of strategic climate action planning. In strategic climate action planning, understanding really based on understanding the biogeochemical context of an urban metabolism, as well as the socio-economic context. And then recognizing this so-called socio-environmental interface, and based on this knowledge, formulate some strategic action planning targets, and also a specific plan, including measures and indicators and so on, how they can be reached. So we think this is a theoretical construct for understanding and governing the urban metabolism. And we try to apply this framework to 2 specific case studies in the past. In the first try on a New York plan for a strong and just city, so the One New York City action plan, and to the resource strategy of the city of Zurich. In both documents, they try to address carbon flows of the urban metabolisms of New York and Zurich, but they also already start addressing material flows, which is also interesting from a regenerative perspective. So just as an example, I would like to focus on this material flow regulation in Zurich. And with their 2050 resource strategy and related documents, they aim for complete recycling of construction materials within the city. So they want to lower resource input flows and resource output flows by reaching a complete circularity of construction materials within the city. And they also work towards recycling of phosphorus, and we will get to the example of phosphorus also in a second. They do this with specific targets. They are transparent about what they're doing in publications. They publish regular progress reports on what they reach, and they also fulfill a certain level of participation, is what we found out in this comparative analysis. And now I would like to dig a bit deeper into the example of global to local phosphorus flow management. Why does that matter? You might have seen this planetary boundary study that shows phosphorus as one of the global problems that is already ranked here as a high risk problem that's related to eutrophication that comes with too much phosphorus in fertilizers, mainly washed out to water bodies. And you can understand 3 challenges from a perspective of regeneration. One is eutrophication, as we've seen in this planetary boundary study. Another one is potentially in the future scarcity of phosphorus, and we need phosphorus for any kind of food production. And the third dimension is an environmental justice perspective, because as you might know, phosphorus resources are only out there in a few geographic locations all over the world. And in the study that I would like to present you from the Urban Footprints Project, my PhD student, Lisa Hasheim, she analyzed the city of The Hague and the phosphorus steering that could happen at that city scale. And for understanding the global phosphorus relationship, she tried to find out where the phosphorus inflows from the Netherlands actually come from, and they actually rank from the top 5 here. The number 2 is Brazil, as one of the main phosphorus exporters to the Netherlands in terms of food flows, so phosphorus concentration in the typical Dutch diet. And then she did a substance flow analysis, applying this methodology from the natural sciences to better understand the urban phosphorus flows in the city of The Hague. And you see flows come in, so it's foodborne phosphorus flows that comes in here through food and drink, import, and then the main flows actually then after the household consumption go through the sewage system, mainly into sewage sludge, and then bottom ash, as it usually lands on landfill in the end if it's not recovered. And then the other important track is through the solid waste system here. And in a classical system, you lose all these phosphorus resources to a landfill or to water bodies or groundwater, which then leads to eutrophication. So we have quite a good influence theoretically at the city scale to regain phosphorus here and then use it again as a fertilizer in the area or in the country. And to understand the city scope of influence, she did a multi-level governance analysis, starting at the European Union level, covering the Netherlands, Delftland regional area down to the city of The Hague. And there is more and more policies adding. Also, a new incentive was the circular economy policy at the European Union level that trickled down to Netherlands Circulaire 2050 and to a circular economy plan also of the city of The Hague that is important in this context. And she could show in the end of this analysis that using a wide range of modes of governance, not only regulation, but also softer instruments like self-governance, provision, enabling, partnership, and experiment, you can come up with a whole bunch of flow measures here that then actually help to recycle phosphorus from different streams. So from solid waste streams, from wastewater streams, also and influence streams on food and produce. The whole policy grid is as large as this, but I only put an excerpt here. So you can see that there's a lot of measures you could take at the urban scale to have a more healthier phosphorus flow system at the city level. And so the final results of the study were that strategic local phosphorus planning can meaningfully contribute to avoid eutrophication from nutrient pollution, preventing threats to food security due to phosphorus scarcity, and it can also help to restore environmental justice in global phosphorus flows, since it's reducing this international resource flow from very few places that also might want to use the phosphorus resources themselves. So key components of strategic local resource governance would be that it's really very fundamental to understand the resource flows in the urban metabolism. So some natural science knowledge is really crucial here. Then we have to understand also the local scope of action in a multi-level governance system, and then actually use all modes of urban governance and go beyond regulation to address those flows. And then at the urban level, you can do really meaningful contributions in all those 3 fields that reach really from local to global to contribute to a restorative phosphorus relationship. Thanks a lot for your attention. I hope this was clear, and I'm looking forward to your questions in the discussion.
Thank you very much, Catherine. It was great. I'm curious to ask some things, but we'll do it right after our other invited guests speak, okay? So yes. Now I'll please call Professor José Antônio Marengo Orsini. He's graduated in physics and meteorology by Universidade Nacional Agrária, a master's in water resources engineering by Universidade Nacional Agrária in Lima, Peru, the PhD in meteorology by the University of Wisconsin in the USA. He has done postdoctoral studies at NASA and Columbia University in New York and at Florida State University in climate modeling. He was the scientific coordinator of climate forecasting at CPTEC Inc., and he's currently a senior researcher and general coordinator of research and development at CEMADEM, our National Center for Monitoring and Alerting of Natural Disasters, where he works with extreme events, natural disasters, and disaster risk reduction. Professor Marengo, thank you very much for being here with us. And I'll start to present the screen with your lecture. So let's
Okay. Okay, Tatiana, thank you very much to organizers for inviting me to this very interesting meeting. As soon as Tatiana posts my presentation, now that's Bucherichie. No, that's University of São Paulo. No way.
Don't worry, I'll just put the other one. I just changed everything. So sorry.
That's
but
fine.
Now I'm going to put it.
Well, when I retire, I'm dreaming to go to work for University of São Paulo. So, okay. Well, thank you very much again for the presentation. I will give my climatologist point of view in terms of the topic of this presentation. If you go to the next one, please. Yeah, in terms of climate change, I'm a climatologist, and the reason why it's extremely important because several of the weather phenomena and extremes that are already happening everywhere, and those projected to happen in the future will have the cities as the main victims, I would say. I'm talking about the bigger cities, the metropolitan, as well as the small ones. In terms of what evidences we are already noticing now is in terms of global warming, for instance, the warming, not warming, is warming of the oceans, reduction in sea ice, reduction of ice caps in mountains. That's extremely important because several South American cities, such as Bogota, Quito, Lima, and Santiago de Chile, depend on water coming from those mountains. And if the snow disappears, we will have water crisis in there. And in the case of Lima, the problem is already there. Then reduction in snow cover, sea level rise, which is extremely important for coastal cities, and the most important cities are actually in the coastal region. And there are some evidences that the sea level is rising, and then together with a combination of tropical storms, for instance, or extratropical storms, the coastal flooding is becoming more frequent and dangerous. The reductions in sea ice, weather and climate extremes, particularly events that have to do with cities like the extreme winds, the extreme rainfall events that produces landslides and flash floods, I mean as natural disasters, and then ocean acidification. The next one, please. Well, in the case of Latin America and the Caribbean, according to IPCC, there is data showing that warming is already going on in there. We took a similar approach and we plot these warming trends or cooling trends, temperature anomaly trends in the Caribbean, in Mexico and Central America and South America. And we noticed, for instance, that the last 10 years have been the warmest ones. And depending on the region, 2020 has been the second warmest, or in Mexico and Caribbean has been the warmest, okay? Like in the case of South America, for instance, the warming has been of the order of 0.6 degrees relative to 1981-2010. And those maps below, this is the temperature anomalies just for year 2020, sorry. And as you notice, the red dots shows warming, the blue dots the cooling, the warmest is the most intense red, and you notice basically that from Mexico to Argentina, all regions are really experiencing warming, and particularly southeastern Brazil, when the major cities are located. And in terms of rainfall, again for the 2020, green is more rainfall than normal, and brown is less rainfall than normal. For instance, we have seen the episodes of more hurricanes in Central America in 2020. That's the reason why you see the green color, which means more rainfall than normal. And in South America, we have the droughts affecting the La Plata Basin, the Pantanal region, southern Amazon, while we have some tendency for rainfall above normal in some cities in northeast Brazil and in the Amazon, which is basically a consequence of La Niña phenomenon that year. But what is extremely important is this drought that started in 2019 is still going on in 2020 and even 21, affecting the Paraná Basin and the Pantanal region and the southern Amazon region, with huge impacts in population and on biodiversity. Next one, please. Well, for a study we did for data in terms of rainfall extremes, we have the station of the University of São Paulo above, and below we have the station Mirante de Santana of the Meteorological Institute, both in the metropolitan region of São Paulo. And the blue bar shows number of days with rainfall above 80 millimeters, and the orange bar shows the number of days with rainfall above 100 millimeters. So we are talking about very intense rainfall events. So what have been noticing in this city, as in other metropolitan regions, is like the number of days with 15 millimeters have been increasing, and even though the number of days with 100 millimeters. For instance, between 20 and 2020, we have 11 episodes of rainfall above 100 millimeters. When we compare with the 60s or 50s, it's just 1 or 2, which this shows some tendency for increasing the number of extreme rainfall events. And the extreme rainfall events in the region of São Paulo are important because are the ones that trigger natural disasters, particularly landslides and flash floods, both in the rural area and also in the surrounding regions of the metropolitan, which is important because landslides are the natural disasters that kill the most people in Brazil. Next one. A similar analysis we did for the city of Belo Horizonte. The city of Belo Horizonte in the state of Minas Gerais. This is the number of days with rainfall above 80 millimeters. And we include 2020, sorry, it says 2019, but it goes to 2020. In the city of Belo Horizonte, between 23 and 27 January, it rained 321 millimeters in 3 days. And the climatology for the month is 329. So basically, 97% of the rainfall was concentrated in 3 days. And if you see the figures to your right, those are the impacts of rainfall in terms of economical damage and in terms of people affected. You see the city of metropolitan region of Belo Horizonte with the purple color, the dark purple color. So with this particular event, one extreme has really having a lot of problems, bringing a lot of damage, economical damage, and 56 people died as a consequence of this. So imagine this, if the city is not adapted or not prepared to getting extremes like this more frequent and more intense in the future. Next one, please. Well, recently we published a paper in Nature about adaptation. When we consider adaptation as the option to cope with the impacts of climate change. So basically we are facing a planetary crisis. We don't have to wait until 2100. We are already having that problem now. And there is a need for interdisciplinary, actually transdisciplinary adaptation research. It's not just the climatologists or the geographers or the engineers. We need teams working in co-production with the state or federal or municipal governments. There is a mention of the Metropolis project. The Metropolis project was a project funded by the Belmont Forum. In the case of Brazil, it was funded by the FAPESP. And it's extremely important because this project involved a collaboration between scientists from various institutions of the state of São Paulo, from the coastal city of Santos, which is the main port in Brazil, for tourism and for freight. And the results of this project were adopted by the city practitioners. So the government of the city took the results, and since we started working with them in the co-production way, all of these results from the academic project, I can say, actually went to the creation of adaptation plans and climate change plans and mitigation plans for extremes in the city of Santos, which means basically the application of the science knowledge to policy making in this city of Santos. Next one, please. Well, in terms of projections, these are the projections from the IPCC models. If you remember, the IPCC is the Intergovernmental Panel on Climate Change. They have produced the summary for policymakers of the Working Group 1, and the analysis, different from previous reports, is according to levels of warming. If you see, for instance, 1.5 degrees global warming, 2 and 4 degrees warming. If you recall the Paris Agreement and then the COP26 in Glasgow in the United Kingdom, the idea is to try to limit the warming to 1.5 or 2 degrees. With mitigation options, deforestation is going to be reduced, the emission of gases is going to be reduced. So you see 1.5, you see the annual maximum temperature, the annual total precipitation, maximum 5 days precipitation, which means extreme rainfall, and then consecutive dry days. And if we have a warming of 1.5 degrees globally, in the Amazon region, in southeastern Brazil, our warming will not be that high. We will not go beyond 2.5 degrees. And in terms of rainfall, for instance, is going to be an increase of rainfall of the order perhaps of 5% in southeastern South America, including southern Brazil and northern of Argentina. And this is important because this increase in rainfall is in the form of extremes, if you see the figure of maximum 5 days. So it means that we may have more rainfall, but in the form of more extremes. And if you go to the 4 degree global warming, the tendencies are the same, but the colors are more intense. So what does it mean? That in the Amazon and northeastern Brazil, we will go to warming beyond 6 degrees, which actually will imply some of the collapses of the forest, and then a major problem for the cities in terms of adaptation because the excessive warming, and also the increase of rainfall will be in the form of increased rainfall extremes. And at the present, currently, for the last 50 years or so, we noticed that the rainfall increase has been in the form of more extreme events. So what is projected is going to be something similar that is already observed but amplified. And if in the present we have an increased risk of natural disasters and hot periods between rainfall events, I mean rainfall concentrated in few days, in the future there will imply an increase of the risk of natural disasters. So it means that the cities are supposed to be ready to adapt to this, otherwise vulnerable people will keep dying. People living in vulnerable regions, will keep dying as a consequences of the extreme events, which actually are consequences of global warming, but in the future, these extreme events will even more extreme and more frequent. Next one, please. And this is from a paper we produced recently. I mean, you don't have to go into details, just to see, first in the maps, 1.5, 2, and 4. That means the level of warming is 1.5, 2, and 4 degrees. And if you see in the first three, ABC, on the upper part, index of changes in index of potential for flash floods. The red colors means increase in the risk of flash floods as a consequence of increasing the rainfall. And if you notice 1.5 degrees, the red color in southern Brazil and southeastern Brazil, and then if you go to 4 degrees, the red color extends even for regions like part of southeast Brazil, south of northeast Brazil, and even the west part. Meaning that those regions where the most important cities are located, there is an increase in the potential for flash floods, which will even worse if the warming is above 2 degrees centigrade. The same tendency down there for the landslides. And if you notice again, when 1.5 degrees and 4 degrees, the red color is more extended in 4 degrees. So will mean that the risk of landslides will be even higher, particularly in the southern and southeastern parts, but will include also parts of West Central Brazil. So remember that the most densely populated cities are located in southern and southeast Brazil. So if those cities are affected by natural disasters in the present, with 1.5 degree warming, perhaps the impact will be still there, but not that high. But if the warming reaches or surpasses 4 degrees, there is going to be really more impacts, more potential for disasters, and the possibility of adaptation is going to be very, very low. Next one, please. Well, just to finish, when we talk about cities, climate information, prevention for risk disasters, risk assessments, and regional adaptation, extremes reveal the signs of human-induced climate change and in climate extremes in the recent decades. There are several papers that have been published that shows the fingerprint, what is called the fingerprint of human activities, basically in the increase of greenhouse gases and land use in some of the extremes that have been affecting the world. Changes in the frequency and intensity of the extreme events increase with each increment in global warming. So if we have a 1.5 degree warming, we will have the changes which will lead to some risk of disasters, and if we have a 4 degrees warming, the changes will be more amplified, will be covering a more geographical region. So that's the reason why they say changes will be greater with 2 degrees warming compared to 1.5. Ideally, it's almost impossible to reach 1.5. I don't say to reach, is to keep the 1.5 level, because it seems like if nothing is done, we may go to 3 degrees centigrade. And if you notice, some of the compromises and agreements from the COP26 are more in the conditional way. No, maybe it's possible. I don't think that, let's say, from the 1 and 10 degrees of optimism, I will be in number 7. And then there is always the probability of low probability, high impact outcomes. Like, for instance, the sea ice collapse, abrupt change in ocean circulation, some of what is called the extreme compound events. It's not just one extreme, it's a combination of extremes, like a drought, heat compound event, a drought in the Amazon, in the Pantanal, and a heat wave in the Pantanal that actually multiply the effects and the impacts of the current drought situation in 2020, now in 2021. And one of the main reasons that make certain regions more susceptible to natural disasters is disorderly urban occupation. So if we have this non-climatic component that has to do with governance, flooding and landslides could be avoided with preventive measures. So even though if we have more rainfall in the future, if we manage to, let's say, don't build housing or don't put people in areas vulnerable to flooding or landslide, we may be preventing future damage. But as the ways the cities are growing, they are building everywhere, including in cities that in the past were not vulnerable to landslides, to flooding, to inundations, but they are already now. And I see every summer we see these examples of people dying because of landslide or flash flood, even in metropolitan regions like São Paulo, Rio de Janeiro, Salvador. So basically, we are experiencing now in 21, in all the recent years, the situation that could be expected in the future, and cities have to be ready, otherwise they will become really perhaps the most impacted. And if we add the problem of sea level rise and coastal flooding to the coastal cities like Santos, Rio de Janeiro, Fortaleza, Recife, we will even multiply the effects. We will have coastal flooding and a combination with coastal flooding with landslides. So meaning that the potential impact on population will be extremely higher if nothing is done to reduce the warming levels. Okay, well, thank you very much, and looking forward for the questioning and debate, I would say. Thank you.
Thank you very much, Professor. We have some interesting questions and comments coming in, but we'll bring this to the discussion right after Professor Marcos, our next invited guest here, presents. I'll just open his presentation because we had a last change. Hold on just for 1 second, please. I'll have to open the last version, and then I'll open it to you so that we can present. Professor Marcos, hold on just 1 second. He's organizing my messages. WhatsApp is with this new now, but that's okay. We have already here. It's opening. Hold on. Okay, now we do have the last one. It's here. Great. So I'll present Professor Marcos, and thank you very much for accepting my invitation, Professor. Professor Marcos Bucherichie is Associate Professor at the Department of Botany in the University of São Paulo and Director of the Instituto Nacional de Ciência e Tecnologia do Bioetanol, that gathers 32 laboratories in 6 states of Brazil, with several collaborations in the US and Europe, and also Deputy Director of Centro de Processos Biológicos e Industriais para Biocombustíveis. He was also Scientific Director of the Brazilian Bioethanol Science and Technology Laboratory in Campinas, develops research on plant cell wall degradation and on the physiological and biochemical responses of plants to the environment. In 2010, he was appointed a lead author for the next Intergovernmental Panel of Climate Change report that was released in 2014. Professor Bucherichie is also the coordinator of the Synthesis Center, USP Global Cities of the Institute of Advanced Studies of the University of São Paulo. So, Professor Marcos, thank you again. I'll present the screen and the word is yours.
Thank you, Tatiana. Do you hear me well? Okay, thank you. Thank you again, Tatiana, for the invitation. You jumped one, yeah, you're jumping ahead. I would like to thank the organizers, Tatiana included, and the UCS for the invitation. It's an honor to be here with Professor Catherine and José Marengo, a dear friend, José Marengo. I would like to say that if it is your dream to come to the University of São Paulo, we can discuss that. The University of São Paulo would be very glad to have you as one of our researchers. Well, because I knew I was going to present last, I brought some information about what knowledge we have to apply now if we want to face the climate change in cities. The next, please. First, I would like to remind you that this is extracted from the report, the special report from the IPCC, the Intergovernmental Panel of Climate Change, released in 2018. I was one of the authors in this report, and this tells you that in this gap between 2030 and 2052, if we don't do anything, we will cross this barrier of 1.5 degrees. The problem of crossing this barrier is having the effects that Professor Marengo just described. That could be the extreme effects would become even more extreme and cause several problems. Among these problems, the next please. When I was working in the chapter 4, mainly in the chapter 4 of the IPCC, we discussed in chapter 4 what technologies are available for the future, and technologies for mitigation and for adaptation to climate changes. And I have added here the transition between today and when we cross 1.5. I hope we don't, but if we cross, we would have to have transitions at the agriculture level, at the ecosystems and forest level, at the coastal systems level, and right in the center you have the urban transitions. Why? Because most of the people will be living by 2030. We are going to reach the mark of 80% of the population of the world living in cities. I won't go through every detail here, but you can see we have several technologies that are related to agriculture, urban ecosystems, and coastal systems. And I added these small circles that are yellow, green, or red, according to the cost, the speed to deploy the technology, and if politics is pro or against the technology. So if we look, for example, at bioenergy in the mitigation, that a medium cost and a medium speed, and the politics is in favor of bioenergy. If we look at now to the right-hand side, to the adaptations, we have, for example, biotechnology tools like producing transgenic plants that would change the quality of food, so that we can adapt the plants and have less effect on the food production. And you can see there that the cost is low, the speed is medium, and the politics is medium as well. And one of the main problems that we have related to the climate change that is not within the city, part of it is in the city, is the food wastage. It's not food waste, it's food wastage, according to FAO, because it means that we lose 1/3 of the food that is produced in the world. 1/3, 1/3 is lost in the production, in the transport, and the consumption of food. And this is really very important. And regarding to cities, this is quite important as well. So there are many others. While I spoke, I think you could take a look at that. Now, I would like to switch to the next one and tell you about the view that we have of what is a city. That's similar to what Professor Catherine had said already. We see the city as an urb system. So the idea is more than the metabolism. Of course, the metabolism of the city exists, like Professor Catherine said, but the whole, biologically speaking, is more like ecology, is more like an ecosystem in which products from agriculture and industry enter the system, and all this is processed within the city using water and energy and producing waste. So the sustainability of a city will be as higher as less water, and less energy, and less waste, therefore, is produced. We call this, Professor Arlindo Felipe and I call this the primary urban system. And there is a secondary urban system. You can see the people in the middle, and there are several tertiary urban system surrounding it. So the environment, health, education, security, food. So in a city, if all these tertiary urban systems work well, the sustainability and the well-being for the people that live in the city will be higher. So it's this balance between the functioning of everything is very important. What happens with the climate change is that climate change attacks many of these systems, and with these it affects the ways we can use to reach sustainability, and this decreases the well-being of people. Like, for example, the environment is attacked when the temperature increases and we have very strong storms, for example. Housing can be affected, for example, if we have the rise in the level of the seas, right? Communications could be affected as well, security, and many of these tertiary urban systems. So in fact, what climate change does is an attack to the urban system. If the attack is too strong enough, for example, to very, very large droughts like we have in Brazil nowadays, for example, affecting the production of energy. If this is too long and too strong, then the urban system could be severely affected, and many people will perish. Many people will suffer with that. Another dimension, another point of view from the cities, is it next, please? Is related to the knowledge. So this triangle here, inside the triangle is what we call the primeval soup, in which ideas for solutions are floating together with problems that are pointed by the aspirations of people. Aspirations here means what people want for the future. And for this, the people point this directly, but the media, the art, and the society in general is very important. The producers of solutions are the researchers mainly, not only, but mainly. And there are two types of research: the research oriented by theory that can become research holding future prospects, and research oriented by problems. So we spot a problem like the climate change, or a sub-problem, a subset of the climate change, and we produce science for that. The problem that we have now with the climate change is that we have no time. As you saw in my third slide, sorry. By 2050, between 2030 and 2050, we may have really very hard problems to solve, problems related to the effects of climate change. So we don't have time to do basic science that could be used in time for us to cope with the adaptations that we have to make. So we have to use the science that is already in our hands. And the other problem, which is the COPs, like the one in Glasgow in the last couple of weeks, is the politics. The politicians, when they are clever enough to make their decisions, they will have an agenda, and they can have the priorities listed in such a way that they would have problems that already have solutions proposed by the scientists, and they can solve the problems. But unfortunately, this is not the case in many places of the world, and we call all these the governance. So the word governance is very important, which is discussed in the COPs, but the local action can also help a lot. And when I say local action, I'm talking about the people and about the government of the cities, the governance in the cities. So this is the way we see the city, as an urban system, and also as a possibility of using knowledge or knowledge-based actions that could help us to face what is going to happen in climate change. Next, please. So when we think of the climate change, we have drivers, we have impacts, and we have solutions. The drivers are the greenhouse gases, the food wastage, as I mentioned to you, deforestation, the use of fossil fuels, the construction with concrete that is a great emitter of CO2, and emissions from fuels in general. The impacts that we have among the main impacts would be flooding, like Professor Marego just showed, heat waves, increase of inequality, because the poor people is the people that are going to suffer more because they won't have enough money to protect themselves or to make the adaptations. So the governments have to provide, and governance has to consider that, and also the indirect increase in pollution. And the solutions, we have already several different technologies that could be used. One that is now being discussed in general in the world is the nature-based solutions that collectively are have a number of different strategies to use solutions that nature already has for us to cope with the climate change. The change in construction technology, new materials for construction that mitigate more. Change in agriculture, we can use REDD+. Brazil developed a very good system to manage the forests, taking into consideration the people who live there. Unfortunately, the present government of Brazil is not working with that, but this is a fascinating way to deal with the forest that people all over the world are copying Brazil, but Brazil itself is not using it adequately anymore. And also agriculture, ecological agriculture is also a way to go. There is a lot going on in research and technology in this case. The increase in tree coverage. Tree coverage, I'm talking directly about cities. So when we cover a city with more trees, we have the temperature is lower, pollution is lower, there is more water vapor, so there is much more comfort for people in many ways, including psychologically, people feel much better in a green city than in a gray city. Afforestation is part of the tree coverage. The cities that don't have enough trees can have more trees, plant more trees, and strategically produce that. This is not free of charge. There is a cost to do that. Increasing water use efficiency. This is a very big problem because drought is one of the main effects of the climate change. So if we could increase the efficiency of how we use water, is the same as using food, is the same as the wastage that I mentioned before. The use of renewables and BECCS, bioenergy with carbon capture system, I'll talk about this in seconds. Increase in sustainability in general, and geoengineering that are solutions that are very difficult in terms of governance. But all this right-hand side here is related to governance. So let's just take a look very quickly at some of the possibilities. Next, please, land use change. So what can we do? The production of food is not a direct part of the cities, but they are directly related to the cities because they produce all the food and fiber and many of the goods that will enter the city, as I mentioned before, and the urban system. So improved climate services could really help a lot agricultures to produce more efficiently, produce food more efficiently. Behavioral shifts are very important. If we continue to consume meat in the way we are doing, we are going to produce a lot of greenhouse gases. So eating less meat or developing technologies that will lead us to consume less meat would be important. Afforestation and deforestation, taking care of the forests, is very important because they determine the climate together with many other variables. Ecosystem restoration, Brazil is very good at doing that in the tropical systems. São Paulo, for example, the state of São Paulo has generated, recovered 5% of the rainforest. So this is a very nice example that the technology can help, but it's slow. This is a slow technology, so we have to start now in order to get some effect by 2050. And precision agriculture is one of the technologies that we can use in all the agriculture side. So next, please. So if we look at the city as a whole, some of what I said before is repeated here, but just I would like to highlight the urban green is very important. I put some pictures for you to take a look. Compactation of the cities is very important as well. More compact cities are cities that produce less greenhouse gases, and they influence less the environment. Food waste I already mentioned. Energy use efficiency is really very important. The home office effect, this came after the pandemic, and is quite important because the home office can help us to increase the efficiency of use of energy and materials and fuels. So we have to think about that. Human construction, already mentioned. Electrification is very important, that people look very carefully at electrification, because if it's to produce electrification and the electricity will come from thermoelectrics, you are not doing anything. You are just taking the dirt and putting it under the carpet, as we say here in Brazil. So electrification has to be coupled with biofuels, as I will show next. Flexitarianism, just a second. Flexitarianism means consuming less meat. That has an effect, and change of behavior, like using bikes, for example, could decrease the consumption of energy. So most of this in the city is related to the consumption of energy and what I said before, consumption of water. Next, please. To produce energy, I'll give the Brazilian example. We already produce sugarcane, so Brazil has the greenest energy matrix in the planet. So we use gasoline and we use diesel still, but we use a lot of ethanol in our cars. And the ethanol, what we are doing now in a project that I'm coordinating, the BEX project, together with FAPESP and a company here. The idea is to use the hydrogen that is in the ethanol to produce fuel cells with this hydrogen and produce electricity, so that we could couple biofuels with the production of electricity. And with this kind of electrification, we could really decrease the emissions here. Together, when we know that when we produce bioethanol, there is some CO2 that is produced in the dorms of fermentation, for example, and we already have everything in place in the state of São Paulo to store carbon about 3 kilometers below the surface, and keep it stored for a very long time. So with this, we expect our system of energy production will be so green as to get us to negative emissions in the near future. Next is bioengineering. So this is very polemic. It's very difficult. For example, solar radiation management. If we put particles in the stratosphere that could spread the light and then decrease the temperature in the surface, will this have an effect in agriculture? We don't know. Who is the person or the country that will press the button to do that? This is very difficult to do. Carbon dioxide removal is a new industry. Many people are working on that, on using carbon for production of new materials that could change our way of construction. So these technologies are already becoming available, and very, very quickly. Earth radiation management is more or less the same as the above. And the urban green I already mentioned, and the afforestation as well. And the last technologies that I would like to mention to you, next slide, please, is that nothing of what I said is possible without democracy. This is really a very important. All the issues related to democracy. So we need to find new ways to increase participation of people. We need to hear and decide based on people's wills. This is all related to democracy, right? To develop faster ways to decide. Democracy is usually very slow, and this is a big problem. We can see that in the COPs. They are always very slow at making decisions. Speed up science-based public policies and deployment. We have to go very fast. Otherwise, there will not be time before we have very strong effects. So this requires that we invest more in areas of research like the political sciences, management and administration, business development. We have to develop this a lot in order to couple the technologies that we are becoming available with the deployment of these technologies and the governance of the countries, the cities, and the states where states exist. So this is what I wanted to say. Then the next slide has my contacts. So those are what I think some of the technologies for resilience of the cities of the future. Thank you very much.
Thank you very much, Professor Marcos. My time is limited, but we would like to hear you a lot more. And now we have some questions that our audience sent us. And I'm going to say one for each one of you, okay? So please, I'll just ask to bring together, yes, Professor Marengo, Professor Catherine, and now I'll just ask you to try to answer these questions in a brief way so that we can listen to all of them, okay? So the first one is from Professor Carrillo, sorry, to Professor Catherine. Thanks for a stimulating presentation. Would you find social ecological economics a consistent perspective with the view of urban metabolism you presented? Professor Catherine.
Okay, thank you very much for the question. Now it would be nice to have a live conversation. Then maybe Professor Carrillo could also detail a bit more what's behind that. So for now, I mean, I understand the idea of metabolism, me as a lawyer, as a quite flexible concept. So it's mainly about understanding different flows, or also seeing a city as an ecosystem. Pointed out, and I would say it can go theoretically with any attitude of also social ecological economics. So I would understand this as a possible way to interpret it that way. For me, I just see it as important to connect an understanding of urban carbon and material flows, and here I focused on resource phosphorus flows, but I could have had the whole talk on greenhouse gas emissions as well. So understanding really the local urban contribution to climate change or to phosphorus flows is a fundamental requirement for designing tailored governance interventions. So for me, it's important to bring those two worlds together, the natural science research and then also anything that's related to governance. And of course, social sciences and also economics and all the disciplines that Professor Bucherichie also just listed play a key role here. And as also Professor Marengo said, I'm totally convinced that we need more of this transdisciplinary research where we have researchers from different disciplines, but then also practitioners from cities to come together and develop a tailored understanding of the urban metabolism and the flows, but also finding locally specific solutions that work. Because even if you think within Germany or within Brazil, different cities function differently, and what works in one city might not work in another city, also from a governance perspective, because of some historical components, some political majorities, whatever. So it's always important to have this adapted understanding that's city specific, and there I think you need both perspectives. And yeah.
Thank you.
Yeah.
Thank you, Professor. Now we have a question for Professor Marengo from our dear Kathy Garner. Professor, we need cities to adapt, but cities must also look to change to mitigate the temperature rise. So how best can we combine these aspects in cities?
Well, this is supposed to be done when the cities plan. I mean, cities which are already there, like São Paulo, Rio de Janeiro, any big city, San Jose dos Campos nearby, they just look for the urban aspects. I mean, they have a small garden here, a small parking there, and they call themselves ecological. When the reality is that to build cities which are, I would say, resilient to whatever could happen with climate in future is not just the greening part. The greening part will help to reduce the temperature higher. I mean, it's basically to try to keep a contrast of temperature. That's the reason why we have lakes in Brasilia. Otherwise, without those lakes in Brasilia, that will be like a desert there. So to regulation of temperatures. But what the cities need to do now, because they cannot be rebuilt again, is in terms of efficiency in use of energy, in use of water, in the treatment of garbage and any type of residual, you see basically recycling. So there are several things that needs to be done, but the cities which are already there with perhaps a thinking on the 60s or 50s whenever climate change was not a big problem. And with the population growing by almost 30 to 40% in the present time, I mean, it's like if the city is going to grow up in terms of extension, there have to be some sort of codes of urbanization. There have to be a possibility of using solar energy, wind energy, biomass energy, trying to make the cities more efficient. And that's something that the population can do, but not just the population, also the municipal governments. I mean, the municipal governments, they will not do if the population doesn't push for it. So I think is basically cities need to adapt, but they want to grow, they want to change. So there is a process after adaptation with this transformation. So we have to transform the cities. I mean, it's nice, we will have more gardens, more parks, more green, more water, but that probably will not be enough because you make let's say you make a beautiful part of the city resilient, but in the outskirts of the city where poor people lives, without doing anything that, I mean, the problem will continue because the people living in those vulnerable areas, if they lose the housing, they will move to the beautiful parts of the city and they will create and increase social problems and social tension. So let us think that climate change is not just changing in temperature, changing in precipitation, it's also an increase of social tension among population and governments.
Thank you, Professor. Now, Kat is asking Professor Marcos. She has two questions, so I'll bring it together, Professor, and then you can consider part of each, okay? First, she asks, why are compact cities more efficient? Does this mean less travel or something different? And then she please asks if you can tell a little bit more about the RED, the redução certificada.
Okay, what of course is mostly related to transport, to transportation, right? If you have a more compact city, if you think of the big cities in the world, one of the most compact cities is Barcelona, is an example. It's a city that is very compact, so you take much less time and much less energy to transport yourself to another place. But there are, and it's the same for the transportation of food, for the transportation of fuels, etc. If you sum all that, then compactness make this difference. If you go the other way around, for example, and if you look at how the Americans have their cities, they have there are calculations that are fascinating. People to get to a supermarket in the US, they have to drive a long way and find a parking lot in a very difficult place, etc., etc. So it's they use much more energy for what they are going to buy in a supermarket, for example, than a person living in Barcelona, right? Or even in Sao Paulo, where we have a very compact city as well. The RED Plus is a system that we were using in the Amazon. Is related to the investment of money that was being made by oil companies in the Amazon that was blocked by the actual government of Brazil. This money is managed in such a way that when they deliver the money and local people have to provide a project with very specific and clear targets and objectives, and they first do and then they get the money. It's different from getting the money ahead and you don't do anything. So it's a very efficient way to do it, and it contemplates very well the local needs of people, right? So the RED Plus, if adapted to different forests in the world, and different parts of the Amazon are very different among themselves as well, but you can use this in many different ways. It's a very nice model of managing projects that are not scientific projects, but projects for development of people who live in a region near the forest. They have to have projects that have the least impact on the environment.
Thank you, Professor. Now we have a question for the three of you. And I would like to thank the participation of Professor Kathy and Professor Francisco. And now this question is from Rafael Perini. He says, as panelists addressed the environmental theme as central in their presentations, I ask, with the end of COP26 last week, how optimistic are you with the agreement signed by the parties? So let's start with Professor Catherine.
Okay, thank you. That's a big question. Yeah, so as a lawyer, I would say it depends. From a climate change perspective, it's of course pretty frustrating. One more frustrating outcome of an international climate change conference, and considering the little amount of time we have to keep the 1.5 degree target reachable, if at all, there should have been done a lot more, certainly, than could have been achieved. But from a legal perspective, I also have to recognize that international law, as we do it, and as also a democratic view, as also Professor Bucherichie pointed out, is made by consensus. So every country on board of these 190 something countries has to agree to every word of such an agreement. And if anyone has ever participated in one of these conferences, it's really a huge effort to negotiate every little detail of such an agreement. So in a way, from this perspective, it's a bit of a wonder that we reached those agreements in the first place. So I'm somewhere in between those two extremes. Of course, you can start discussing changing decision-making to majority voting at the international scale, but I'm not sure if every country would be happy with such an approach. Or you could change to 3/4 or 2/3 majorities, as we sometimes have that at the national scale, when you want to change constitutional rights or something a bit more fundamental. But that's a very difficult debate, and we made first steps into those directions at the WTO, but not at an overall international level. And I'm not sure if I would be a fan of that actually either. And yeah, but if you want to also have some positive feedback, we at least we touched this topic of methane, which I think is important. And a bottom-up initiative, again, a voluntary initiative. So this new regime of the Paris regime that also builds on building bottom-up dynamics, also with this outreach to non-state actors over this NASCA platform, non-state actor zone for climate action, where cities, regions, companies, investors can voluntarily participate and more get over to net zero pledges by 2050. There is a specific dynamic triggered by this international regime and the way it is designed that hopefully will be fast enough to also be a good basis for heads of states to progress a bit faster in the future. So yeah, I'd say it's not enough, but at least it's better than nothing would be. Yeah.
We need to have a positive view also.
Yeah.
Thank you, Professor. Professor Marengo?
Well, yes, we need to have a positive view. Like I said, the Paris Agreement, which was used as a reference. It's important, of course, the agreement in terms of methane, because that has to do with agriculture and agribusiness in Brazil. I mean, they are not too happy that this agreement was signed, because that may have a strong impacts in the beef industry, for instance. But there are some activities itself. I mean, some of the agreements that were done because of international pressure and because perhaps they will be implemented whenever this current government will be over in 2023. So perhaps they just will leave the hot potato for someone else. But I think in terms of the methane agreement, the agreement between countries to reduce their emissions, of course, not to disregard totally the carbon or coal, but at least reduce them, it's good enough. I say, like I said, in between 0 and 10 are we 7th in optimism. But the thing that was really very sad, it was that the Brazilian participation was divided in two groups. The government, some of them, I think there was more than 100 people delegation, including wives and kids, which I'm not sure if they were in the agreements, but also the other part, which was the non-government organizations, the Federation of Industries, the governors working together for Amazonia and Northeast Brazil. So this kind of division, it doesn't look good for anyone. It doesn't show the unified Brazil. So this kind of agreements in terms of reductions of emissions, the reductions of deforestation, without having the unified view of the country, it's basically worrying. Okay, well, the agreements are there, it has been signed, let's hope that it works. Whoever assumes the government in 2023 will have to deal with what is proposed in this COP26. I mean, I was really very optimistic at the beginning, but later on, with all these negotiations and conversation, my level of optimism went a bit lower. Of course, I don't want to be pessimistic, because that will mean the end, basically. But like I said, I mean, things could be better. But I think some agreements, like the methane, are clear. And Brazil actually was able to participate in some negotiations that in the previous COP, they didn't even appear. And I think the negotiators from the Ministry of Foreign Relations and Ministry of Environment, Science and Technology were much better this time than on the previous year.
Thank you, Professor. Professor Marcos?
Well, being optimistic or pessimistic depends on how you look at the COP26 or any COP, right? Because this is the COPs are mostly a scramble of things that have in fact no direction, and there are these resolutions, but this is not really organized, as we can see from all the COPs, maybe except for the Paris COP that was really more deterministic and with agreements that meant something, but not everybody followed, right? Then we have to look at the three levels, the global level, what I call the medium level, and the local governance level. At the global governance level, which is what we see in the COPs, we have to be pessimistic, because, like, for example, from the point of view of Brazil, not having Brazil present, although they participated in some negotiations, but our president was not there, the message was not delivered, and Brazil is known as a leader, and the environmental issue is very important to us. So is there hope? Can we be optimistic or pessimistic? Or for the scientists, it's amazing. There was a survey made by Nature magazine just before the COP, in which scientists responded to the survey saying that they are moving from their houses to another house because they don't believe anything will happen. And those are the scientists who work for the IPCC and for the science of climate change. So there is pessimism there in the medium level, but there are also people like Marengo and myself. I don't know about Professor Catherine, that are optimistic. I am optimistic, and I can see more optimism. Just to finish my comparisons here, Tatiana, I see more optimism in the young people. So we see, for example, the phenomenon of Greta Thunberg that is speaking out. I finally understood, because I couldn't understand why Greta Thunberg was so valued by the media, etc. But then I gave an interview to people from the favelas, from the periferias in Brazil. And in this interview, my interview as a specialist was surrounded by the opinion of young people that are very hungry. They went to the COP and they are very hungry with these guys discussing the top level, the governance level. So this is where the hope resides. Right, so the absence of Brazil is bad, but the people that were there, Indian speaking and young people speaking, and from the poor side, this bring us some relief of optimism. And I would like to say a last thing that is a phenomenon that was sort of maybe unexpected for many people. That, for example, São Paulo now. If you drive in São Paulo now, you see signs saying São Paulo, the capital of vaccination, right? Although our government, by ideological reasons, kept saying that do not have the vaccine, people didn't care and people vaccinated. And so we have now 100% of people vaccinated in São Paulo, and the disease is very low. So this is where the hope resides, right? In culture. If we can change culture, if people could behave differently, and Brazilians especially, I think the Germans as well, the Dutch as well, many countries that I know in the world are the same. So we have the inception of that the environment is important. No government can fight against that because it's our culture.
Yeah, and for me, there are 2 points that keep me optimistic. So one is the lead of the local governments to sustainability. I think while we have all these problems with the federal government, local governments bring our discussion to a whole new level, and we may realize that we have a lot of advances, even though they are not exactly what we want, but we are going forward. And I think this is really good to see, and not only in Brazil. We can notice this in a lot of countries, that the federal authorities do not represent what the population thinks and wants. So this is really good. And the other point is what you mentioned before about the youth. I really believe that this youth, that this new generation is coming to change, to fight for, to battle, to talk, and to protest, but also to recognize that it's possible to have these changes, to transform. And that's why I thought one of the main points that Professor Catherine brought was about the planetary boundaries. Because I think when they realize how this works with those flows and those charts, we can think about maybe downscaling the planetary boundaries indicators to city scales, and then bring this to use to reinforce the operational scope of the urban sustainability agendas. And then we can have this transformation, then we can have these changes that we want. So now, because of the time, unfortunately, I have to end this discussion that's really nice. And I'll just ask 1 minute, the final words. Let's start with Professor Marcos, then Professor Marengo, then Professor Catherine, and I'll get back to just close our panel. So, Professor Marcos. Okay.
I already said most of what I wanted to say. I just I would like to leave you one term. Behavior is hope.
Go on, Professor Marengo.
Yeah, I think I said what I have to say in terms of science and interaction between science and politics and people's participation. But I think what we need is basically a better transdisciplinary work among scientists, but also we scientists become activists. Otherwise, our science will die in a paper that nobody will read next year or the next 20 years, and our names will be famous, but not for someone like help to build something concrete. I say what we need is, we, Marcos and several others, we are doing so already with seminars, presentations, and we need to keep doing that. Otherwise, whatever message we have in terms of climate change, impacts on urban quality of life in cities will be in vain. That's my only message.
Thank you, Professor Catherine.
Yeah, maybe I can add to that. In a research project in Hamburg, we tried to assess the social plausibility of deep decarbonization by 2050. And we were identifying different drivers of change and knowledge production by the science and climate protests organized like by the Fridays for Future movement around Greta, climate-related regulation, climate litigation, technology development, were all journalism as well, media, were all important drivers. And we were trying to assess how they come together to produce this social dynamic towards deep decarbonization. And I really hope that this transnational outreach that the Paris regime created beyond what's typical under international law, reaching out to cities, regions, companies, investors, and so on, will be sufficient to create a social dynamic that actually will make possible that we reach those targets. Because I deeply believe in this relationship between individual, local actors, companies, and so on, and then this overall international system that's more like a tanker flow, too slow, if there's not enough pressure coming from the bottom up. But I think we have also more and more of this global up movement, and I really hope that there will be more pressure from the people, from cities, that we get this tanker on a higher speed.
And I really hope we can meet together again, but maybe in person, so that we can have more discussions and be together and change this knowledge and these perceptions of what is needed, because it was a great pleasure to have you here. So thank you, Professor Catherine. Thank you, Professor Maringo. Thank you, Professor Marcos. As Monica just said here in the comment in the chat, she said, thank you for the last comments. Empowerment is so important. The new generation needs us, and the solidarity of older generations. Thank you all. So important and interesting thoughts. And that's, I really believe so. So the key is how to communicate. We produce knowledge, but we need to communicate this. Professor Marcos always teaches us how we need to challenge ourselves to get the information to who needs and to who can make the difference. So let's continue doing this. And thank you again by heart. It was very good to have you here. And now I'll just announce the next panel, Plenary, that you will have in 2 minutes. It will start. The Most Admired Knowledge Cities Award, Legacy and Future. So thank you again. Please stay well, take care, and see you next time.
Thank you, Tatiana, everyone. It was a pleasure.